2003 Chevy Suburban 1500 chassis with the 5.3. Customer complaint is when it's cold out, it has a long crank time and it doesn't even start until it warms up, it seems like. That's what I've been hearing anyways. So we're going to address that. Also, he's saying the battery goes dead. I don't know if it's one night or a couple nights, but we're going to check for parasitic draw. We got the charger on it now because the battery is weak. So what we're going to do is we're going to go do a full system scan with the Untitled. So we'll go auto VIN, auto detect, and then we'll pull up the data. So let me get this pulled up, and then I'll come back and show you what we have for codes. So I identified the VIN. I'm going to decode it now. Pick all the RPO stuff on it. 2003. Come on. Using the GM program. Diagnosis, we'll do a full system scan. Auto scan. So let me scan this whole entire thing and then we'll come back and show you what codes we have. Well, almost done. There we are. It's done scanning. So let's go into the modules, take a look. Overview. PCM. So we got a mass airflow P0102. Sensor circuit low frequency. Fuel trim rich bank 1. Fuel trim rich bank 2. Fuel composition sensor circuit low frequency. Throttle actuator control module position performance. FFT turn start enable signal not received. An encoder circuit malfunction, that must be in the automatic transfer case because it has auto 4-wheel drive. Class 2 data malfunction, link malfunction in the airbag S supplemental inflatable restraint, which is the airbag. BCM class 2 data, headlamp circuits, heating and air conditioning module has a temperature control circuit malfunction. So what we're going to address is the issue that's what's causing his crank no start when it's cold out is the PCM one. So we're going to go to trouble codes, read codes. So we got 6 in the PCM, 1 in the ATC, automatic transfer case. Automatic transfer case is a history code, encoder circuit malfunction. We can address that another time, but there's basically a ring in there. It gets 0 to 5 volts reference, and it basically tells you if you're in 2 high, 4 high, 4 low, 2-wheel drive. Just said 2 high. Auto 4-wheel drive. We've done this before. I don't think I've ever done a video on it. They're not too bad to do, to troubleshoot, but we can look at that at another time if need be. But what we're concerned with is the PCM codes. Mass airflow, low frequency. So it's a current diagnostic trouble code. It passed and failed. This last test it hasn't ran because we haven't ran it. We just got key on, engine off. Alright, so the other one we got is fuel system rich bank 1, fuel system rich bank 2, current DTCs, pass and fail. Haven't ran it yet for those tests because we haven't run the engine yet or ran the engine yet. Fuel composition sensor circuit low frequency, same thing, P0178. Throttle actuator control, current DTC P1516, and the theft one I'm not concerned with because it's pass and well, it's driving. They might have, I don't know if they used the wrong key or something, but these two have passed in the recent ones. So because when you first turn the key on, engine off, these have to pass, otherwise it won't, you know, nothing will turn on. So what I want to look at now is some freeze frame data to see when these codes actually when I throw the codes, what actually happened. This pulls up. So let's look at the 172 Phil Rich Bank 2. So that's pulling up Rich codes are 172, 175. Lean codes are 171, 174. If you had a lean code, 171, 174, it means it's got a vacuum leak, mass airflow issue, you know, weak fuel pump perhaps. There's tests. I've done another video to address that. I've seen where these plastic manifolds leak. Hook up a smoke machine, and you can test it that way. But we have 172, 175 rich codes for bank 1 and bank 2. There's not too many things that make a rich code. So what we could look at this is we have some anomalies, right? We have low frequency on the mass airflow. We have a fuel composition, low frequency. Maybe that's what's going on with it. I know on the newer Chevys, well, actually, let me start over. The older Chevys like these have an actual fuel composition sensor that has a little microprocessor in there that checks it. Well, in the newer Chevys, like say 07 and newer, they actually have a logarithm. Well, when you're actually using ethanol gas, which they don't on this vehicle because there's no E85 out here, but if you were to, it needs a lot more fuel to compensate for that ethanol gas, and in turn your fuel trim would be rich if you weren't actually using ethanol gas. So that's another anomaly we got to look into this as well, as far as troubleshooting. So the 172 rich, it was at, you know, 1200 RPMs. Coolant temperature almost warmed up, 171. See if any of this data helps. APP, throttle position, fuel tank, barometric pressure, map sensor, mass airflow. Let me see if I can get metric units here. Mass airflow was 12.75 grams per second. Closed loop, so short term and long term, -11 short, -12 long for bank 1. You have those together, you're at -23%. Typically, Chevys will throw, you know, rich codes when you get below -20, 25%. Lean codes when you get above 20, 25%. This case we're lean or rich. Bank 2, same thing, a little bit more for this freeze frame capture. If there's anything else we can use. They're running for 4.5 minutes. So now let's look at the 175. It's probably gonna be roughly the same data. Obviously both banks are running rich, so what feeds both banks or what reads is mass airflow, map, and the fuel composition sensor. So let's go to 175, which is bank 2. And it's around the same RPMs, 1200. Use off idle. Yeah, fuel trim, -22 total for bank 2, short and long. Yeah, those together. See if there's any data we can use. So it's at a higher RPM range when it's running. 16 grams per second, which you expected more because you're a little bit higher RPMs than the other one. And then what we need to look at is our freeze frame for, or I believe it's P0178. When this goes back to the screen. Alrighty. Yeah, right here. P0178, fuel composition sensor, low frequency. Our battery's really weak. We need to get that addressed too. Way weak. Freeze frame on this, idle basically, 600 RPMs. Let's see here, map sensor, mass airflow, 5.8 grams per second. So you should typically, you know, at idle, no engine load, 5.3 grams per second. So anything typically over 3 liters. So if you have a 5.3 grams per second, no defrost on, no loads on the engine. If you had a 6.0, 6 grams per second, roughly. Closed loop, fuel trim's good for short term. Long term's off, obviously. But that's just at idle, so short term is good at idle. Let's see what else we can use here. So what we need to do now is we need to run it and check the frequency of the mass airflow and the frequency of the actual fuel composition sensor. I know the mass airflow at idle should be around 2,000, 2,500, depending on elevation. So we'll take a look at that and go from there. All right, we got a battery all charged up. So I pulled some live data up. Engine speed, desired idle is 562. We're around there, so that's good. Mass airflow is 6.1, 6.2. We should be at 5.3 grams per second, and this frequency in hertz here should be at, you know, 2,000 to 2,500 at idle. We're at 2,700. Well, if it's that excessive, then we're going to actually have more air going to it and turn the computer's going to give more feel. But another thing we noticed, look at your field trims right now. When I first started this, these were negative, short terms were negative 2 or 3. They're going way up. Negative 9, 10, 11. Well, the fuel alcohol content when I first started showed 4%. Now it shows 38%. Well, it's not 38% alcohol in this. I have other videos where you can measure the alcohol content with water and all that. But here's the thing. It's an E85 vehicle, but there's no E85 in Mountain you can put in. So we'll talk to the customer to make sure he's not been using that, because if this is saying it's 38%, what is the computer doing? It's adding a bunch more fuel to compensate for its suspected alcohol content, because it doesn't burn as efficiently, so you need more fuel. And then the O2 sensors are picking it up, and it's saying it's a rich condition on both banks, 172, 175, hence why he has a long crank time and it won't start sometimes. So that's wrong. And then fuel composition sensor frequency shows 0 hertz right there. Our mass airflow is a little bit better there, but let me show you some service data now for the actual to get it over here. The 178 is the fuel composition alcohol content sensor, which, remember, we had it's showing 38%, which is completely wrong. That's why that's direct correlation to the fuel trim in the rich codes such as 172, 175. So this DTC of 178 shows the conditions for setting the frequency. Fuel composition sensor frequency is below 45 hertz for 12.5 seconds. Well, frequency we have 0 hertz for like the last few minutes. So now let's go through the service data a little bit more. So alcohol content and fuel temperature information is supplied to the PCM from the fuel composition sensor, which is called the FCS. The FCS has an ignition 1 circuit, a signal circuit, and a ground circuit. The FCS uses a microprocessor inside the sensor to measure the ethanol percentage and the fuel temperature and changes output signals accordingly. The signal circuit carries both ethanol percentage and the fuel temperature within the same signal. The signal is both variable frequency and variable pulse width. The frequency signal indicates the ethanol percentage. So the frequency signal indicates the ethanol percentage, and the pulse width indicates the temperature of the fuel. The PCM provides an internal pull-up of 5 volts on the signal circuit, and the FCS pulls the 5 volts to ground in pulses. The normal range of operating frequency is between 50 and 150 hertz. So it shows normal range is 50 to 150. The normal pulse width ranges from 1 to 5 milliseconds. If the PCM detects a signal less than 45 hertz, this will set. Well, 50 to 150 hertz is normal. We're only getting, well, we're not getting any. We're getting 0 hertz. And I believe that's why the alcohol content is so high. So now we can run through this chart, but I take these with a grain of salt. We're going to go ahead and we're going to take the DMM, digital multimeter, and start probing, wire integrity to that sensor into the mass airflow, and continue to troubleshoot from there. All right, so we're going to do some circuit testing now. So what I'm going to do for this fuel composition sensor, You have 3 wires, right? You got PCM1 fuse, 15 amp. You'd have 12 volts down there. You have a ground to ground 104, and then you got the white wire going back. So we can check power and grounds. Pin B and pin C, 12 volts and ground. Make sure that's good. Depending on what we find from there, we could be a problem. Then we can check this wire here back to the PCM. What you need is like a signal generator to send signal back from here to the PCM. If we need it, we can use a signal generator here and set the right frequency, like 60 hertz, say, because it's 45 or 50 to 150, so I guess we could do, 60 hertz. And then check it on the scan tool, make sure it's reading. Then we'll know that wire's good. And then we can also, I guess we'll have to check all that and see what's going on. And depending on what it is, if we got a wiring issue, wire integrity issue, if we got a sensor issue, that'll help. We'll find the problem. That'll address our fuel trim issues, which can be in correlation to our MAF sensor issues. So we're going to use the kit from AES Wave for breakout leads. Got our DMM, scan tool, signal generator if we need it, test light. So what I'm going to check first, since I got the vehicle down on the lift, I want to check this fuse, PCM1 fuse, 15 amp. I don't know what I just clicked on there. I hate these damn Google books or whatever. The Chromebook, sorry. I mean, they work for basic stuff, but I don't know. I guess I'm not used to them. So I'll check that fuse, PCM1. And it says hot and run or start. So key on engine off, or you can have it running, which we do now. Take my test light. Go to battery ground. Always check your test light, make sure it works. It does. PCM1 fuse is this guy right there. So to the right of that, which is to the right of that. So that's the fuse right there. Test light should light up on both sides, which it does. So that fuse is good. So now what we're going to do is we're going to go under the vehicle with some breakout leads and check the wire integrity down there. Alright, got it back up on the lift. I got my negative lead from my DMM. I'm going to battery ground, that way I have a good ground. What I'm going to look at now is pin B, circuit 439, the pink wire. I should have 12 volts there. So we come under here. It's messy, got all the snow. So pin B is the pink wire. Because right here is your alcohol content sensor, fuel line in, fuel line out, 3-wire sensor. Pin B's pink wire. Take my other lead here. Sorry, I'm trying to film and do this at the same time. Got my breakout leads in there. I should have 12 volts. And I got nothing. So, why don't we have any voltage there? So what we can do now is I can go to this pink wire. Not pink, we are on the pink. You can check the ground on the black one. Should have no more than 30, 50 millivolts. Make sure we got a good ground. Let's go to the 2-volt scale there. Let me switch my leads real quick. Use these breakout leads. Probe this. Checking ground. Don't worry about my polarity's reversed. We got 0.022. Let's go to the smaller scale. 23 millivolts. Don't worry about the negative. I can reverse my polarity on this. It doesn't matter. So we got 23 millivolts. It's a good ground. Now I can check the white wire. And I imagine I would have a 5-volt reference when I do that, because this is going through the actual module. Now we got to get to the right scale here. Yeah, I got a 5-volt reference, so that's good. So it looks like we have no power going to that thing to complete the circuit. So what we're looking at there, this computer to come back alive. We had 12 volts at the fuse, but nothing down here. Our ground to 104 was good. And then this wire here from the PCM, we had a 5 volt signal. So now we got to find a way you don't have 5 volts here. Or we could back probe it and then give it 12 volts to see if everything reads accordingly. So we'll get some more tests and go from here. Alright, so what I'm going to do now is just to show you, we had the 5 volt reference, so our frequency should be good. So this wire at pin A, the white wire, we can send a frequency back with the frequency generator to the PCM and read it on the live data and the scan tool. Because right now, it's not reading. Fuel alcohol content says 38%, so it's taken, or adding a bunch of fuel, and the O2 sensor is picking up as a real rich condition because it's really not 38%. I mean, that would be very excessive because our fuel we put in Mountain Home is only up to 10% ethanol. So, zero frequency there. But what I'm doing here is I'm using my frequency generator. I want to get the new MaxiSys Ultra scan tool because it has this guy built into it. But I just got it on a 100 ohm scale. I got a square wave. You can use sine wave. But we're just going to go on a square wave. Got my output. It's my B and C connector. And I got my 2 leads coming off here. So I got the positive going to the white wire on the left and the negative going to the black wire on the right for ground. And all I'm going to do with the engine running is I'm going to turn my frequency generator on while you watch the camera, and that should go up. There we go, 84 hertz. So I'm going to adjust this, move this down and up, and that'll change the frequency. So if I go up, you know, goes to 1, whatever I'm changing, I can move it back down to 60. So what does that tell me? That tells me that the wire from the PCM or from this field composition sensor to the PCM is good to go. Well, why isn't this thing working? Because we have no power coming down here. So what we can do now is we can plug it in, back probe it, give it power, and see if we get the same results. I don't believe our field composition sensor is bad. We actually have a issue with the actual wire going to it. And I imagine when we clear all this data out, everything will go back, you know, alcohol content will go back to, you know, 4% or whatever it really is. Because it's actually going to read the alcohol content in the actual vehicle with that logarithm, not logarithm, but that microprocessor. Our mass airflow is pretty good right now. It's actually pretty accurate, and so is our mass airflow. So now what we're going to do is turn this guy back off. When I turn this off, that should go to 0. I'm going to plug it back in, and we're going to give it power and do the same checks. Alright, so what I'm doing now is I'm taking a wire from the battery positive and I'm plugging it back in. I'm back pinning the pink wire to give it 12 volts with everything plugged in. And if you look, my frequency is 51 hertz and my fuel alcohol content's going down. It's already at 25%. So it doesn't have a power, it has a power issue to this module. And now that we got the right frequency, well, it's based on the alcohol content. Now that we got power going to it, our frequency is reading, and look, our alcohol content's dropping. It went from 38, 25, 24, it's dropping down. Because what it's doing is it's actually reading the alcohol content through that processor. Sorry, that was my son calling me on Facebook Messenger. But, he wants to be over here working on this car, I guess. So yeah, I'm going to go back and we've got voltage going to it. No, look, it's at 19%. So it's going down. It's actually reading the actual alcohol content in the vehicle, which is going to be less than 10% because any fuel pump you go and get around here in Mountain Home, Idaho, they say less than 10% ethanol. So we're going to let this go down. There, it went to 18%. What's that going to do? It's going to actually fix 17% our fuel trims. So I went to some fuel trim data, short-term bank 1 and 2. It's actually starting to correct itself. The long-term still negative. We can reset all the fuel trim, but it's improving itself. So now the fuel trim will get a lot better, and it won't have a rich condition because, like I said, that sensor wasn't working because it wasn't getting voltage. We still got to figure out where the broken wire is or why it's not getting voltage. But when we power it up like this, now it can read correctly. But when it's not reading correctly, it says it has 38% alcohol, which is wrong. But it thinks it does, according to that sensor, so it shoves a bunch of extra fuel in there because it's not as efficient with the E85. And then O2 sensors pick it up as a rich condition. That's why it has a long crank time, not running very good. Probably crappy fuel mileage. So we got to go through and find that broken wire after we do some more data. Alright, so let's look at fuel trims again. Look at mass airflow. Now, mass airflow is a little low. Should be around 5.3 grams per second, but we can check that. It may have a little dirt on the hot wire resistor, but not really concerned with that now. So what I want to look at is the fuel composition. Breathing frequency, 0% alcohol, so red. So our fuel trim's getting significantly better, but to start fresh, what I want to do is go to special function, and I want to reset the fuel trim. Sorry about the glare. I'm going to reset the fuel trim counters. That zeroes everything out. And we're going to go back and read fuel trim live data. So I reset the fuel trim counters. Mass airflow, we're in closed loop. Short term 1 and short term 2 is pretty close to 0. Remember, 0 is perfect. Plus, I like to see 5, 7, no more than 10% positive or negative. Short and long term fuel trims. We're well within the specs. Now it's learning, it's fuel trim enabled right now. It's going to adjust because it's learning right now. Fuel alcohol content's 1%. We're reading frequency, so we're well within our specifications. But fuel trim's enabled. The reason I say that is if you go to special function, fuel trim enable, it's learning every time you reset that fuel trim, and it's always running at different RPM ranges, different engine loads. It needs to learn it, so it's enabled right now. You can see it. And there's different blocks of cells. That's fuel trim cell 17, for example. At idle, this RPM, this temperature, they may call that's block 17. It needs to know it's short and long term, different RPMs ranging. So it's learning, everything will even out. So we found that, obviously it's not getting voltage. We're temporarily fixing it now to get everything back dialed in for the fuel alcohol content with this wire. But we got to find out why we don't have 12 volts from right here down to there. From there to there. On the underhood block connector C2 pin A12 down to pin B on that. We've got a broken wire in there or shorted or something. Now when it says RPO code with L59, RPO is your regular production option. You can look in the glove box on these. And L59 means it's basically got, the fuel composition or E85 that it can run. Z71 RPO code is a suspension package, and there's RPO codes for rims and all kinds of stuff, cloth seats, leather seats. But that L59 means we have a E85 vehicle. So now we got to find why on this circuit 439 we have no voltage there. Because what we're doing right now is we're taking a wire from battery, jumping it to there to power this module up, which means everything's working, which is a good thing. We'll address that, figure that out, fix it, run it, make sure everything's good, look at the mass airflow. May have to take it off and clean it, the hot wire like we said, because it's underreporting just a little bit. And if you remember from our codes, we had low frequency in our mass airflow at that RPM range. And maybe it's dirty, or maybe the mass airflow is a separate issue at those RPM ranges. We'll address that, but we got to fix this part first. We definitely had a P0178 low frequency for the fuel composition. Well, that's because it was 0. It needs to be between at least 45, but 50 to 150 hertz. And we proved that with the signal generator. We know why. We'll get that addressed, and then we're going to do a parasitic draw because of the battery dies over a night or a few nights, or something like that. But we'll fix this wire. Maybe this wire is short of the ground, and that's what's killing the battery. But we'll take a look and go from there. All right, so before we start shooting that wire and troubleshooting it, you know, we're going to pull this connector off, disconnect it down there, and check short the voltage, short the grounds, and all that stuff, and opens, and find that and fix that. But it's been running for another 10 or 15 minutes. If you go to engine data, and you look at this data here, we're in closed loop. I'm going to get mass airflow. I want to get short-term and long-term field trims, and I want to get field composition. So we're a little low on our grams per second, right? But like I said, it could be that it's dirty or there's an issue with it, the mass airflow itself. But why was this higher before, way high? When it was running, we first started filming, that's because it was giving it a bunch of fuel, and it's going to rev a little bit higher, and you know, all that. That's why the grams per second and the hertz was a lot bigger, or increased. Short-term, long-term field trim is perfect, pretty much, well within our specification. If I go to imperial units here, and then let's get these out of here to make it easier to see. Fuel alcohol content's 2%. It's calculating it. Frequency 51 hertz. Fuel temperature, you know, same sensor, 62, 63 degrees. So, yeah. So what we need to do now is go ahead and find that. Short the voltage, short the ground, or open wire and see what's going on. All right, we're going to do a parasitic draw test before we start pulling this apart to do our test to see where our open is for the circuit, like we talked about, for the power. So what I do is I hook my DMM up. You always want to put your red lead in the A hole, which is right there, or the milliamp hole. It's for amps. Now, I'm on the 10 amp scale. I started higher because I don't know how many amps it's going to draw. I just take the negative lead off. You can do the positive one too. And I put this meter in series, meaning I got one lead going to the battery, one lead going to the cable, and I had to put a little pin in there because there's corrosion in there. When I first started up, or hooked it up, I was getting, you know, 1 amp, right? Because modules are turning on. If I was to open a door, you want to make sure your lights are off because obviously it'll draw amperage. No cigarette lighter stuff plugged in. And we're at 0.210 amps. Well, that's 210 milliamps. The general rule of thumb is no more than 100 milliamps of draw. But most service manuals, you see 30, 50, no more than 60 milliamps. And we're at 210. So you want to let it sit for 15, 20 minutes, sometimes 30, because all the modules got to power down. This one's been sitting a while. We'll let it sit a little bit longer. And then how do you find, if this doesn't go down, how do we find it? We start pulling fuses one at a time. If we pull this one, nothing changes. This one, nothing changes. But say we pull this 15 amp one and it changes, then we know that circuit is the one we got to go after, which you can do under the hood. Now the ones under the instrument cluster are kind of a pain to get to because you got to open your door, and then it's going to start everything over. So what you can do is you can open your doors, take your door jar switch, tape them shut or wedge them shut, so you eliminate that concern. So we'll let it go a little bit longer. Right, so we're still at 210 milliamps. I'm going to go ahead and pull the fuse that we had an issue with that's powering up. This would tell us if it's a short to ground or voltage, but I don't believe it is. I pull it, nothing changes. We were not going to be that lucky. But if I was actually troubleshooting this, which we will after we fix this wire, I would keep pulling fuses on this to see when it drops. So like I could pull this one. Nothing changes. I mean, it just takes some time to do it. And it may not be these fuses under here. It may be the ones in the inside the vehicle. So we'd have to go and start pulling those as well. Change it a little bit there. Still 200 milliamps, not enough to matter. And it went back up when I put it back in. But Let me pull it again while you're watching that. Yeah, I mean, it's not enough to change anything. Pull some other ones. So I'll keep pulling these. We'll go from there. Alrighty, my assistant's been going through and pulling all the fuses. He's gonna pull that one, pull it. 0.02, so that's 20 milliamps. Put it back in. Put it back in, it's 210 milliamps. So when we looked at that fuse, it's actually this fuse right there, the IPC, the DIC instrument panel cluster, and display information controls. So we pull up a diagram for that, look at it. Or maybe this module hasn't shut off all the way yet, or we got to actually see what that circuit controls and then go from there. But before we troubleshoot that some more, we're going to go ahead and pull this apart and check the wire on the actual, this wire right here from the fuse block to the fuel composition sensor, and see what we got going on with that. All right, so what we want to do is we want to check for that wire now. We'll go address the parasitic draw here after we figure this out. So this wire from connector 2 on the fuse block underhood, pin A12, goes down to pin B. Right, we have no voltage there. So connector 2, A12, you go to the service data. You go back up to show you the pinout. Wish I had a mouse. So right here, C2. I don't know if you saw that right there. C2 is this black one right here. And then if you go to C2, connector 2, pin A12, which that's connector 2. A12 is that pin there. And A12 is pink, circuit 439, ignition 1 voltage with EVA. That's the circuit. Or sorry, not EVA, it's right here. Circuit 439 with L59 is what we have, because that's the alcohol fuel content sensor. And then if you go back to the circuit diagram, 439. So you're going to go ahead and remove this. The other end is open down there. We're going to check for shorts, the voltage, short the grounds, and open, and then go from there. So if you look at A12, bottom left, which is our circuit we talked about, pink, 439, ignition 1 voltage with L59 RPO code. Got DMM hooked up. Always put on the highest resistance when checking short to grounds. Battery ground. Just going to touch it, touch that probe there, or touch that connector for the pink wire, which is right there, A12. Just touching it. It's good. Let's check it to chassis ground. Just going off that. For chassis ground, do the same check. Just touching it. And we're good. So, no short to ground. I know I said earlier we're going to check short to voltage. It's not going to matter, because if we had short to voltage, we'd have voltage on that wire, right? That's not going to be the case. We have an open circuit, so now we got to check from pin to pin, go from there. So now we're going to check that wire. So I got my breakout pin in there, and then got my other lead going down. We're going to put it back up on the lift and check continuity from that end right here all the way down to the end. I don't expect continuity unless we have an issue within this box itself, in the circuitry up to the fuse. And we know the fuse is good, it's getting power, but maybe there's some corrosion there. We'll go from there. We're using the AES wave breakout kit, so now we're going to have to put it up on the lift. All right, so now we got the pink wire with the breakout lead up here, and then we got the other wire on, we showed you earlier in the video where we got it broke out here. We're just using a DMM, and we're going to check resistance. We should have continuity. I don't expect to. It should be beeping. Nothing, right? No, nothing, no resistance. So no short to ground, but also it's an open circuit, which means we had no voltage on this at all. So now what we need to do is find where the open on the wire is. So now we're going to lower back down and because we found kind of where the harness goes up over the transfer case and goes up behind the left head. I'm going to try to get up there and get a good spot. You know, maybe we can use this micro piercing probe to pierce into it, see if we've got continuity on one side or the other, and go from there. All right, so we opened this harness up because it comes from the driver's side. There's a pink wire in here. If you come in real close and look, you can see that. You can zoom in and see it. The wire insulation's together, but these little copper strands, they're broken through. I don't know if you can see that in the video. Wish my cameraman would give me some kind of, you know, head nod. Okay, there he goes. So you can see it broken there. So what we're going to do now is we're going to probe on this side with a back probe. Not back probe, piercing probe. And what we're going to do, we know that's this circuit. So we're going to pierce into this. So we got to fix it anyways. That's going to be the wire going down to the sensor under the truck. So we got a pigtail coming off on the wheel well. Yep, down there. And then we're going to hear this beep. Or we got continuity. So we got continuity there. And I gotta get a better probe in here. Pierce. So we got continuity there. Let me move this back. Right there. So it's all over the place because I'm not in here real well, but there I go. I can touch it now with the bare wire. So we're good there. There's just my piercing probe. So that's the wire. Now we're going to pierce on the other side. And then I like the power probe ones better than these. These things are fucking garbage compared to the power probe ones. Maybe not. Maybe it's just me. Maybe because I'm frustrated. So now we're going to do the same thing, going to the fuse box on the other end of this connector 2A12. Got resistance there. So let me pull this one off. Pull back in that hole there. Yep. There we go. It's got in the wire. So we got good resistance there. So that is the wire. And again, if you can look in there and zoom in, it's broken. And I wonder if it's broken because it goes around this bend here. So if you zoom out, I'll grab the camera. And then maybe get a better angle from up here. Yeah, right. How the hell is it? Right there. Copper strands are broken, and maybe it's the way it bent around this bracket right there was chafing. There's another wire in there. This one too looks like an orange wire having the same issue. I don't know what that one origin powered is. It's not broken all the way through, but we need to fix this one and fix the other one, and that's the issue with this fuel alcohol content sensor. And we need to also finish our parasitic draw and to look at our mass airflow issues and go from there. So like I said, it wore on this radius here because this, you can see it here, this wire rubbed right, focuses right on that radius there, wore through the insulation on the first side, the one side, and then broke the copper windings, and that's what happened. There's another wire back there. It's actually pink as well. Look orange, but it's faded there. When we get back farther, it's pink. So we're going to fix those wires, get this routed correctly, make sure there's no extreme pressure on it like there was and no chafing. Go back to our parasitic draw, fix that up, and then do our mass airflow. So I may include us all in this video. If not, there'll be a part 2. So now we got to fix these wires. So I went and took a jumper wire for those that wire that's broken. And if you look, our frequency's back to 51. Our alcohol content started at 38 because when we had it unplugged, it went back up to 38. Now it's compensating again. But if I unplug this wire, when it unplugs the wire, it'll drop to 0 hertz. There's 0 hertz. And then this number will go back up. Look, it's starting to go back up. Went from 30 to 31. It takes a few minutes, but it'll start going back up to 38% max alcohol content, because 0 hertz, that's what it equates to. That's why the fuel trims are all off. So that proves, and it takes a little bit to process, 3031. It'll go back up to 38%. We'll let it run here for a minute. All right, once it's unplugged again, it'll eventually go back to 38% with 0 hertz on the frequency. So it takes some time for it to catch up, but what we're going to do now is we're going to look at the mass airflow issues, look at the parasitic draw issues, fix these wires. I know we've kind of been back and forth on, you know, the issues, but there's several issues with this vehicle as far as the drivability issues, so we'll continue to address some more.